Welcome everyone to this talk on developing a data-centric NLP machine learning pipeline session. And it's my pleasure today for me to introduce Diego Castaneda and also Jennifer Bader from the Shopify team. Diego is a data scientist with a background in computational astrophysics, and he currently supports the needs of the messaging team, which gives entrepreneurs the tools to connect with their customers and also collaborating with their teams. And Jennifer is a content designer. She has been in the field of UX content design and communications for the last 10 years. She is passionate about using conversation to humanize e-commerce. So Diego and Jennifer, take it away.
Awesome. Thank you very much to everyone joining, and thank you for David and all the organizers for giving us the opportunity to share this with you. Our talk is called Developing a Data-Centric NLP Machine Learning Pipeline. As you heard, my name is Diego Castaneda. I'm a data scientist.
And I'm Jennifer Bader, a content designer. And next slide, please.
It is there. We work at Shopify.
Okay. For some reason, it's not showing up on my screen as the next slide, but that's great. So yes, Diego and I work at Shopify, and Shopify helps aspiring entrepreneurs go from just an idea to a thriving and fully scalable business. We provide merchants with all the tools they need to start, manage, and grow their business. Next slide. Diego, I think you're going to have to let me know when you advance the slides, because I'm for some reason it's not showing up on my screen as advancing.
Oh, okay. So we're now our focus.
Great. So Diego and I work on the messaging team, and the product we work on is called Ping, which is a free messaging app that is used to drive sales and also build customer relationships. And today we're going to share about a project we've been working on, and we're going to highlight some of the adventures involved in developing a data-centric NLP machine learning pipeline. We'll share the outcomes to date with you, and we will reveal some of the learnings that we've had. So as Chenyan said, we do hope you have questions or comments about our presentation, so please do record them in the chat, and we have saved some time at the end to address them. So we're going to talk about the message classification project that Diego and I have been steeped in. And so you'll see on the screen a visual, and it shows an online store with a chat window. And in the message field, that allows customers obviously to reach out to merchants if they have questions when they're shopping. So the focus of our work on this project was identifying topics from these incoming customer messages. And the reason to identify them is that will allow us to use message classification to build a suite of features that are centered on the chat exchanges between merchants and their customers. And so ML-powered natural language processing is a key that unlocks us being able to do that.
All right, so our approach to develop such system involved various components. Like one of our ideas was to use a state-of-the-art, robust, pre-trained NLP model. These are becoming easier to incorporate in our pipelines, but we also, of course, needed relevant training data set so that we could fine-tune that model. And the idea, the hope, was to achieve a highly accurate model that we could trust so that we could build features around it and deploy it in real time for real-time classification. And of course, monitor it in production so that we could understand how everything was happening once deployed. A fairly standard traditional approach when you develop this kind of systems from scratch, because there was really no precedent in our very specific product and domain, was to create a semi-supervised data set. And you do this by exploring sort of like the conversation space, like messages, a high volume of messages, try to find clusters of topics and see how you can support those clusters by pulling more data. And this process is basically fairly standard. Like it produces a training data set with a set of categories identified from this exploration. It's very visual. You can see that. And then you invest a lot of time in optimizing and tuning the best possible model using that training data set. So one of the problems we found, like we went through that whole process, but one of the problems we found is that our data is very unbalanced. So some of these clusters represented topics that were too broad, like the boundaries were not very well set. So the model that we trained from this was actually not very accurate, but most importantly, the probabilities associated with the classifications we could make were fairly average. So we didn't cover a lot of a large volume of messages with high confidence classification. So that basically blocked us from continuing our approach. So we had this already easy way to pick pre-trained NLP model. We put together this training data set, but the rest of the steps were sort of like blocked because the model was not accurate enough. So we really didn't deploy it for any real-time usage yet. So instead, we decided to put in everything and focus on redeveloping or recreating this training data set. And that's what we're going to basically tell you about, so that it basically unlocked the rest of the process that we had planned. And that is this idea of data centricity in a machine learning pipeline, especially now that pre-trained models are available and easily deployable in any pipeline. So it really becomes an effort of putting together the best training data set possible. In our case, that is a classification task, developing not just the training data set, but the taxonomy that is representative of our conversation space. So in here, like this is where one of our key things was to bring together our content design team. And now we're going to tell you some details about that taxonomy development and data annotation, which was sort of like the key for our success.
Great, thanks, Diego. So because the taxonomy is so key to developing a successful data set, I'm going to give you a quick overview of our process in creating the taxonomy. So the first step is to start to sketch out the desired taxonomy. So the team did this prior to me joining the project, but they started first by identifying the topics they wanted to see in the new taxonomy. And the way they did that is they skimmed a lot of customer messages manually. And they used clustering visualizations and were looking for trends. And as the team looked at more and more messages, they added more topics. And then when there were around 20 topics, that's when the team realized that they needed help to organize and make some sense of the rapidly growing list. And this is where I joined. And the first thing I did is to review the topics that the team came up with and look for a way to organize them. And I did that by grouping them by their similarities. Now, this is something that sounds a lot easier than it is because there are many ways to group. If you take animals, for example, you can group them by their external coating. So whether they have fur or scales or feathers, or you can group them by color, or you can group them by size. There are many ways to group. But once I came up with a grouping that felt very useful, what that allowed is for us to sort topics into categories, which creates a 2-level hierarchy. And the interesting thing that happened, in combination with continuing to look at messages, is the recognition that separating the topics into categories highlighted the distinction between those messages that indicated customers were in a pre-purchase phase and those who were in a post-purchase phase. And so this pre-purchase and post-purchase added a 3rd layer of hierarchy. Now, the reason why hierarchy is important is when there are a lot of topics. And this is because it ensures greater labeling accuracy because it's an easier way to sort messages. So a way I like to think about it is like, let's say you were doing a 5,000 piece puzzle. Most people, when they dump the box of pieces onto a table, is the first thing most people will do is start sorting all the edge pieces from all the center pieces. And then from there, they might start grouping the pieces by color. And the reason for doing this is because it really limits the amount of puzzle pieces you're looking at when you're trying to find a fit. It's the same thing with the taxonomy. So if you have a fair amount of topics, a tiered structure is important because it makes it easier for annotators to label messages that become the training data set. And this helps ensure the accuracy of the information used to teach the model how to label messages. So next screen. There's a lot of thinking that went into how the taxonomy was going to be used by the annotator. So in other words, thinking about the user experience of actually labeling the messages. We had created, as you can see at the visual, we had created a spreadsheet. You just get a peek at some of the spreadsheet. It was comprised of 5 categories. There were 45 topics. And what we found we needed to do is to pay attention to the way, excuse me, pay attention to the way we named the topics so they wouldn't be confused with each other. We also paid attention to the topic order. So as the annotators were looking through this information, that order would follow, would have some rationality. And so for us, it mirrored the customer journey. And we also included a lot of descriptions for both the categories and the topics. We included disambiguations. We included examples of each topic to help the annotators accurately label the messages. So all of this sounds really straightforward. It's always easy to look back and say, oh, this is the way you do it. But the truth is, to do justice to a taxonomy and the annotation effort really takes a lot of time and effort. So next, let's, excuse me, I need a second for water. Okay, next I'm going to speak about the annotation process. And all the work that was done on the taxonomy is to ensure that the annotation process goes as smoothly as possible. And because we were making up our process along the way, I've outlined some of our process and sharing it with you so you can benefit from our learnings. So our process, one of the luxuries we had is using our customer support team as our annotators. They have a deep knowledge of both our product and our merchants. And so this was really a big win for us. We had setup loops that included training sessions. There were 3 different training sessions we had with annotators. We had multiple practice runs where they were taking actual messages and labeling them. We also had multiple people annotate the same messages, and then we checked them at the end to validate consistency and accuracy. Now, this took a lot of time. It was expensive in terms of labor, but definitely worth it. We also had an active Slack channel for people to post messages they weren't sure about to encourage group alignment. And then we used metrics to quantify agreements. And also during this earlier phase, we allowed for taxonomy refinement. And that's because we would keep encountering new messages that we hadn't encountered before, and we wanted to make sure they had a place within the taxonomy.
So how did this investment look like in terms of results? What was the main outcome of investing so much time in this process? We have here a comparison of how this traditional semi-supervised process looked like in terms of some numbers compared with this data-centric investment we made. And this traditional semi-supervised loop created, we were able to put together 40,000 training messages. That was a combination of sourcing data from the clustering algorithms themselves, as well as a small annotation campaign. It was a 20-topic taxonomy. All came from exploring this clustering analysis. the models that we were able to train that were good had a overall accuracy of around 70%. But most importantly, the confidence of these predictions was fairly low. So only around a third of all messages that we classified, we could consider them as having high confidence, of the model having high confidence. And compare that to this data-centric data set and process that we made. We actually had half of the amount of training messages, but they were all annotated, and they were all supporting this 45 element topic taxonomy. And the models that we were able to train with that had an overall accuracy of around 90%. And most importantly, the confidence, high confidence coverage that we observed is around 80%. So it's a massive improvement, and it was a big effort, but basically by focusing on that aspect of the entire pipeline, we were able to improve significantly the outcome of this whole process. Now, how does the whole pipeline look like the one that is in production right now? So this is a little diagram that basically summarizes the main components. And just want to point out, all the data preparation, all the data development and taxonomy work was done in this corner on the left side. In here, once we had our 20,000 messages, actually a little bit less, we would connect that with our data warehouse, where we would be monitoring things via Jupyter notebooks. And we would be training models using our ML platform modules. They were all a combination of in-house tools, third-party vendor components, and also open source libraries. At the very end, the model that we trained is a TensorFlow model using transformers from the awesome folks at Hugging Face. We chose Distilbert as the model itself. Distilbert is a smaller, more resource-efficient version of BERT that once we tested our production settings, it gave us some great performance. And we finally connected, that model itself is hosted in Google's AI platform for online inference. And the only client of that model is a custom API built with Fast API and deployed on one of our Kubernetes clusters. And we're measuring a latency of around 100 milliseconds for the 95th percentile. So it's an awesome thing that we can now use in real time and connected with our messaging platform.
So basically, our learnings from this process are that there were a lot of learnings. And so we created this slide not to go through each of these points, but we just wanted to convey that there's a lot that we gained from doing this process. We did create a high-level version of our learnings for you, and that is, the first one is that the training data set development can take most of the project's timeline. We knew that we were going to invest the time in this, but we didn't really know how long it would take. And in the end, it took a large majority of the time we spent on this project. Also, the fact that the ability to use domain expert annotators is invaluable. And lastly, the combination of content design, data science, and machine learning teams are a winning combination when it comes to NLP. So there are a lot of exciting things about this project. One of the things I really love is that it set a precedent for future language-based projects at Shopify, which leads to our biggest learning. And that is that developing a data-centric NLP machine learning pipeline is a win. So thanks, everyone.
Great.
If you like what you've heard and you're interested in doing this work yourself, I want to let you know that Shopify is hiring. So Diego and I included the link here for careers, and we also included our QR code with our LinkedIn our LinkedIn QR code. So feel free to reach out to us with more questions. But speaking of questions, right now, we'd love to hear from you and your questions about what we presented.
Yes, thanks, Diego and Jennifer, for a great presentation. So the first question that we have was, you mentioned that there are 20K messages. So how long did it take for you to build the taxonomy?
You know, to put the taxonomy together was probably about 2 months. And that includes the process of using the annotators, running, you know, our dry run-throughs, annotating messages, ensuring that there were representations in the category, in the taxonomy for all the messages. And so roughly about 2 months.
Okay, cool. That's actually shorter than I thought, which is great. So in the process, did you actually find any ways to automate or speed up the process?
Yeah, that's a great question. So,
yeah, go ahead.
So and it connects a little bit with one of our learnings. We don't have like as we set this out, we don't have like specific tools for like taxonomy development and maybe connecting that to like our annotation, in-house annotation tool. So we actually pieced together like what we had at hand. So the automation was really us in the background helping bring things from side to side so that the annotation tool could know of any updates in the taxonomy. The taxonomy, as you saw, was a document that was editable, so anyone could, that had sort of like the development access could come up with like fine tuning and changes. So it was not really automated, but we had a process, and we have ideas now that this was done of like maybe how to incorporate that or integrate it into a single place.
One of the things I'll add into this, though, that was a little, well, for me, you know, we all really wanted to get to the place of training the model. And so multiple times, I think for me anyway, I needed to remind myself, like, slow down. This is manual. It's very hands-on. And that's intentional because of the importance of annotating this first batch of messages correctly, because the whole project, the whole foundation of the outcome is based on that. So in a way, we really didn't, there were aspects that we did not want to automate because we wanted to ensure the quality of the data set, the training data set.
Yeah, that makes sense. So related to automation as well, then how do you anticipate model retraining works then? Does it mean that you need to annotate your data set like every year again?
Yeah, that's a great question. So as you saw in the pipeline, let me perhaps go back. Where is it? In here, even though like some elements are fairly manual in the loops of taxonomy and annotation feedback and whatnot, if new data comes in, like we're basically monitoring the coverage in real time to make sure that that looks like we expected and we saw in training. So, and we also are looking at the distribution of topics that are coming up like on a different like time grain every time. But we're aware that like conversations might change. I think at some point we talked about how, like, for example, the pandemic changed a lot how conversations happened and what terms were being used. So we're basically trying to like create feedback loops to understand if our model is still like good enough. But if we need to make updates, we will basically either bring the data ourselves like to our data warehouse so that a new model version is trained, or more annotations will be needed to connect with our data warehouse so that a new model version is trained.
Yeah. I would say, you know, depending upon how long the model, how long it's used, it's just best to count for the fact that it will change. Because as Diego mentioned, like with COVID, you know, it wasn't until COVID that we started seeing messages related to PPE, which is the personal protective equipment. That term was never included in messages before. And so just as language changes, language is dynamic, it changes over time. Yes, it takes time to change, but it does change. Our model needs to change with it.
Cool.
So,
Great.
so we just plan on the fact, hopefully not too often, but we plan for that, and I think everyone should plan for that, depending upon what they're, if it's related to human language, the way humans speak. I think it's best to, and you plan on using the model for a long time, it's best to just plan on it.
Yeah, especially like you mentioned the fact that there needs to be a feedback loop and monitoring, whether data has changed over time as well. So
exactly.
About that topic. So relatedly, since you have multiple topics, do you actually use one classifier to train on all topics, or do you use multiple classifiers?
So right now we have one classifier. So this sort of deployment, and even though we mentioned we have a sort of like a hierarchy of topics, we actually approach this right now as if it was a single classification task. We have now that this is in production and some features will be built around them, we have ways of improving or ideas of how to improve things from the taxonomy perspective, but also on the type of task that a model might have. One of the things that we made it so that it will be very flexible is that our fast API can query multiple models at the same time. So if we need to have as for processing a particular message, multiple models, like that's available, and we will just adapt to whatever business rules we need to set up so that we get the desired outcome.
Cool. And then audience also has a question about what you have up there regarding the latency. Can you just explain a little bit about the latency, the P95, 100 milliseconds, and if you don't mind, can you also talk a little bit about the RPS here as well?
Right. Yeah. So yeah, that latency is based on the infrastructure that we needed to support our current load. Our current load for incoming messages, like we can basically a single instance of the stillbird using an NVIDIA T4 can respond up to 15 requests per second. And one of the nice things is that at least in this current deployment on Google's AI platform, is it can scale depending on the load. So I would say like an NVIDIA T4 supports the stillbird in the form that we have it right there. As soon as there are perhaps peaks of more than 15 requests per second, like we can scale that up horizontally.
Cool. And following up on that, so are you using GPUs for inference?
Yes. So we're using right now, like we found the most sort of like cost-efficient GPU for us was an NVIDIA T4, which is like meant to be used for inference.
Gotcha. And so let's backtrack a little bit to the model retraining pipeline. So someone is asking whether what tools are you using to version the model and also data?
Right. That's a great point. So we, like that is part. So we're sharing this data platform with the rest of Shopify. So the data itself, like our data warehouse, has a very complex like version control associated to every piece of data that is stored. So as soon as we have new data, there's basically a new version that of our training data set that is stored in that side. And in terms of like version control for the model itself, as soon as we retrain a new one, that's a new version that inherits a bunch of metadata associated with like all the input parameters that went into training that. So it's all very custom made. Like we don't right now employ any specific vendor or library end-to-end pipeline. It's a little bit of a mix of everything basically, and it's all developed in-house.
Cool. So how long did it take for you to train on those 20K messages?
Surprisingly quickly. Like not the hyperparameter tuning, because that takes a while to like to do, but like a single training run on 20,000 messages takes around 35 minutes. Like we're fine-tuning the model, right? So that's the magic of that process, that is not as time consuming.
Wow, that's really short.
Right, and that was using an NVIDIA V100, which is also like it's a pretty good GPU, but not like the largest that you can find these days.
So you mentioned something about feedback loop early on. Audience member had a question about then how often do you actually see a data drift, and what type of tests or how do you actually what are you implementing to monitor the data drift in production?
So we're looking at that right now. So our production pipeline is very recent. So right now, what we are monitoring, like we basically have the history of messages, so we can observe or simulate the behavior of our model looking back, or like excluding messages from that were part of that training. So we can look at things like coverage. We can look at the distribution of topics. But in production, once we start building features, we're probably going to implement some feedback loops that can allow end users to help us figure out if the model is relevant and useful.
Cool, thank you. I think that's all the questions that the audience members have. So let's give a warm thank you to our speakers today, Diego and Jennifer, and we hope you enjoy the rest of the MLOps conference.
Thanks, everyone. And
Awesome.
thanks
Thank you
to
very
David
much.
and team for organizing this. It's been really fun.